I'm the calculus professor, and today I'll be talking to you about polar coordinates. In problem number 63, I'd like to convert the Cartesian curve y equals x squared to polar form. All right, so let's start out. Let's rewrite our curve. We've got y equals x squared. What I'd like to remember is what various things convert over to polar as. The two equations that I'm really interested in right now are that y is equal to r sine theta and that x is equal to r cosine theta. Using these two formulas, I can rewrite this rectangular curve as a polar curve. So y, we know, is r sine theta, so we write that r sine theta, or y, is equal to x squared. Well, x is r cosine theta, so I can say that this is x, r cosine of theta, quantity squared. So I just wrote that y equals x squared. Simplifying just a little bit, I have that r sine theta is equal to r squared cosine squared theta. So I just square that out. And typically what we want to do, if it's possible, is we want to solve this thing for r. Just like in Cartesian coordinates, if possible, we typically solve for y and write y as a function of x. In polar, we'd like to write r as a function of theta. So let's see if we can do it. First thing I see is I have an r on both sides of the equation. So let's divide both sides by r. If I do, I get that sine of theta is equal to r cosine squared of theta. So just dividing both sides by cosine squared theta, I can solve this thing for r, and I get that r is equal to sine of theta divided by cosine squared of theta. Now, that's one way that I could write this equation. I think I could be a little more clever than that. Sine divided by cosine, so sine theta over cosine theta, is otherwise known as tangent of theta. So this is tangent of theta, but then I also have an additional cosine on the bottom of the fraction. So I could write this as tangent of theta divided by cosine of theta, but what I'd prefer is I have an extra 1 over cosine of theta, and 1 over cosine of theta is otherwise known as secant of theta. So I'll just write this as secant theta. So the way that we would want to write this curve as a polar curve is r is equal to tan theta secant theta. And we have our answer.